Hello students, welcome to memoneet. This is Ravikant, your physics teacher, and the question paper we are going to discuss today here is of BPT 12 question paper. And let's look into the very first question. The first question says that a bullet is fired horizontally on a vertical mud wall. After moving x distance in the mud wall, the bullet's speed becomes 3/4 of the initial speed. If the bullet comes to rest after traveling a further distance y, then y is equal to. So in the question, initially the bullet is being fired with, let's say, it travels a distance s is equal and travels a distance s, and it attains a final velocity is equals to 3 by 4 times of the initial velocity, that is equals to u, right? So we need to calculate the acceleration. So we will use the formula v square is equals to u square plus 2as, right? So using v square is equals to u square plus 2as, we finally get our acceleration as a is equals to 7u square upon 32x, right? Now it further moves the distance of y. So distance moved is equals to y. Initial velocity for this will be equals to 3 by 4 times of u, and finally it comes to rest, so v is equals to 0, and acceleration we have here. So again we're using the formula v square is equals to u square plus 2as, and putting all the values as we have put over here. V is equals to 0, u is equals to 3 by 4 u, and a is equals to 7 u square upon 32x, and s is equals to y. We finally get y is equals to 9 by 7x. So the correct answer for question number 1 is option 3, 9 by 7x. Now let's get into question number 2. Question number 2 says, that the force acting on a particle of mass 2 kg is shown in the figure. If the initial velocity of the particle is 5 meter per second, then find the final momentum. If the initial velocity is 5 meter per second and mass is 2 kg, so the initial momentum Pi will be equal to 10 Newton second, right? Now from the graph given here, the area under the curve will give me the change in momentum. So the change in momentum will be equal to half into base into height. So this would result in 100 Newton second. So if change in momentum is 100 Newton second and initial momentum was 10, so the final momentum P final will be equals to 110 Newton second, right? So the correct answer for question number 2 is option 2, that is 110 Newton second. Now let's come to question number 3. Question number 3 says, yeah, question number 3 says the body of mass 5 kg has a momentum of 10 kg meter second. When a force of 0.2 Newton is applied on it in the direction of motion for 10 seconds, what is the change in the kinetic energy? So they say that mass is 5 kg and initial momentum is 10 kg meter second. So initial velocity we can say u is equals to 2 meter per second. Alright. So from here we'll get the initial kinetic energy. Now force is applied as 0.2 Newton for 10 seconds. So we know that force is equals to change in momentum upon time. So this is equals to P2 minus P1 upon T. So F is being given to us as 0.2, and this is equals to P final minus P initial is 10 upon 10, right? So from here you'll get, here we write it here, that 2 is equals to P final minus 10, right? So P final is equals to 12 Newton second, and if P final is 10 Newton second, so final velocity V will be equals to 12 upon mass is 5, so this is equals to your 2.4 meter per second. So from this we'll get the final kinetic energy. Calculating final kinetic energy from here and initial kinetic energy from here and finding a difference, we'll get E, that is change in kinetic energy, is equals to half into M is 5 into V square, that is 2.4 square minus U square, that is 4. Solving this, we'll get E is equals to 4.4 joule. So the correct answer for question number 3 is option number 4, that is 4.4 joule. Now let's come to question number 4. Question number 4 says that two identical magnetic dipole of magnetic moment 1 ampere meter square each placed at a separation of 2 meters with their axes perpendicular to each other. The resultant magnetic field at a point midway between the dipole is. So midway between the dipole is somewhere here, and this is 1 meter. So this is 1 meter. For if let this be the first magnet dipole, this will be second magnet dipole. So the magnetic field because of the first magnet dipole, the point lies on the axial line. So we know that on the axial line, the magnetic field is given as mu naught upon 4 pi 2m upon r cube, right? R cube, or you can say d cube, distance of the point from the center of the magnet. And B2, for B2, that is for this magnet, the point lies on the equatorial line. This is the equatorial line. So for equatorial line, we have magnetic field as mu naught upon 4 pi into m upon r cube, right? So from here we can say that B1 is equals to 2 times of B2. Now at this point, both the magnetic fields will be perpendicular to each other. So the resultant magnetic field B will be equal to under root of B1 square plus B2 square. So this would result in under root 5 times of B1. So this is equals to under root 5 into mu naught upon 4 pi. M is equals to 1 and R is equals to again 1. So we'll get 5 into 10 to the power of minus 7 Tesla. So the correct answer for question number 4 is option 2, that is 5 into 10 to the power of minus 7 Tesla. Right? So question number 5. Question number 5 says that a coil of area 0.1 meter square has a number of turns 500 turns. After placing the coil in the magnetic field of a strength 4 into 10 to the power of minus 4, 10 to the power of 5, 10 to the power of minus 4 Weber per meter square is rotated through 90 degree in 0.1 second. The average EMF induced in the coil is. Simply is the formula based question. We will using the formula is equals to E is equals to NBA by T. Right. So N is your 500. B is 4 into 10 to the power of minus 4. 4 into 10 to the power of minus 4 into A is 0.1. A is 0.1 upon T. So putting the values, we get E is equals to 0.2 volts. So the correct answer is option number 1. For question number 5, the correct answer is option number 1, that is 0.2 volts. It is directly formula based question, and the formula used over here is E is equals to NBA upon T. Putting the value, we can easily get the answer as 0.8. Now let's come into question number 6. Question number 6 says, in an isothermal expansion, the temperature T, the work done in expanding a gas from the volume 2V to 5V is W. The work done in expanding the same gas from volume V to 25V as the temperature T will be. So for an isothermal process, work done W is equals to nRT into natural log final volume upon initial volume. This is the formula used. So for the first case, if we put the values, we'll get our work done as nRT log 5 by 2, because final volume is 5V and initial volume is 2V. So on the fraction, we'll get 5 by 2. In the second case, initial volume is 10V and final volume is 25V. So again, putting the same values in the equation, that is the formula for the isothermal work done, will get work done is equals to your nRT into ln 5 by 2. That is the work done in the first case is equal to the work done in the second case. Therefore, if the work done in the first case is taken as W, so in the work done in the second case will also be equals to W. So the correct answer for question number 6 will be equals to W, that is option number 4. The correct answer for question number 6 is option 4, that is the work done in both the cases is same here. Now let's come to question number 7. Question number 7 says that how many 1 microfarad capacitor must be connected in parallel to store a charge of 1 coulomb with a potential of 110 volts across it. So the charge given to us is equals to 1 coulomb and the potential is equals to 110 volt. It means C equivalent will be equals to charge upon page. And if they are connected in parallel, suppose n number of capacitors are connected in parallel, so their equivalent capacitance can also be written as n into C, and C over here is 1 microfarad. So using this equation, using this part of the equation, what we get is 110 1 upon 110 is equals to n into C. C is 1 into 10 to the power of minus 6 farad. Right, 1 in 10 to the power of minus 6 farad. So from here we'll get n is equals to 10 to the power of minus 6 upon 100, 10 to the power of plus 6, because this will go this side, so it will become 10 to the power of plus 6 upon 110, and dividing this will get approximately equals to 9090.9. So according to this we can say that the correct answer for this question will be option 3, that is 9090. Capacitors when collected in parallel will get 1 coulomb of charge stored in it at a voltage of 110 volt, right? So now let's see question number, let's see question number 8. Now question number 8 says that two liquids A and B of mass 2m and 3m specific heat S1 and S2 are at temperature 100 degrees centigrade and 20 degrees centigrade are mixed together to have a common temperature of 30 degrees centigrade. The ratio of the specific heat is the two liquids A and B. So using the principle of calorimetry, that is heat lost is equals to heat gain. So heat is being lost by the first liquid which is at 100 and reaches to 30, and heat is being gained by the second liquid which is at 20 and reaches to 30. So using heat loss will be equals to mc delta T, that is m is 2m into S1 into delta T, that is change in temperature is from 100 to 30, that is equals to 70, is equals to heat gained by a mass of 3m into S2 into delta T over here is 10, right? So from here we get 140 S1 is equals to 30 S2. So from here we get S1 upon S2 is equals to 30 upon 140, which is equals to 3 upon 14. The ratio of S1 upon S2 is equals to 3 is to 14. 3 is to 14 is the option number 3. So the correct answer for question number 8 is option 3, right? Now let's get into question number 9. Question number 9 says that if the power dissipated in the 9 ohm resistor in the circuit shown is 36 watt, 9 ohm resistor, right? Is 36 watt. The potential difference across 2 ohm resistor. So power is given as I square R. Now from here we can say that current I will be equals to your power upon resistance का root, that is equals to 36 upon 9 root, and that is equals to 2 ampere. So 2 ampere current is flowing here. 2 ampere current is flowing in this 9 ohm resistor. Now if 2 ampere current is flowing over here, it means 36 watt 2 ohm resistor. Okay. Now 2 ampere current is flowing in it. It means the voltage across it will be equals to V is equals to I into R. So V will be equals to 2 into 9, which is equals to 18 volts. Now because 9 and 6 are in parallel, so voltage across this 6 will also be equals to 18 volts. So if in 6 ohm resistance the voltage drop is 18 volts, then current in it will be equals to definitely 3 amperes. So 2 ampere is coming from here and 3 ampere is coming from here, so they all together form equals to 5 amperes, right? Now if this current 5 amperes get into this 2 ohm resistor, right? In this 2 ohm resistor, the voltage drop across this will be equals to I into R, that is equals to 10 volts, right? So the correct answer for question number 9 is option number 4, that is 10 volts, right? I hope the solution is clear. If I redraw the diagram, see, this is the case. This is a 9 ohm, this is 6 ohm, and this is 2 ohm. They are saying that power across this is 36 watt, and that from there we calculate the current entering into it is 2 amperes, right? So voltage will be 18 volt. The same will be across 6 ohm. So here if voltage is 18, so current in 6 will be equals to 3 ampere. So this 2 and 3 combine together and becomes 5 ampere. Now this 5 ampere when gets into this 2 ohm, so the voltage will be 5 into 2, which is equals to 10 volt. So the correct answer is option number 4, right? So now let's get into question number 10. Question number 10 says that the length of a solenoid is 20 centimeter. Okay, the area of cross section is 10 centimeter square, and the number of turns is equals to 100. Another coil of 500 turns is wound in the middle. Their coefficient of mutual induction will be nearest to. So the length of the conduct solenoid is equals to 20 centimeters, so it will become equal to 0.2 meters. Area of the solenoid is equals to 10 centimeters square, that it will be equal to 10 to the power of minus 3 meters square. Number of turns in the first coil is equals to 1000. Number of turns in the second coil is equals to 1000. Mutual induction is being given by the formula M is equals to mu naught A upon I into N1 square into N2 square. Putting all the values which are being provided in the question and solving it, we finally get that the mutual induction is equals to 10 pi into 10 to the power of minus 4 Henry. So again, this is the direct formula based question. So we'll finally putting the values in the formula, we get our answer is 10 pi into 10 to the power of minus 4 Henry, which is in option number 2. Option number 2, right? So the correct answer for question number 10 is option 2. Now let's get into question number 11. A long cylinder solenoid has tightly spaced turn wound in a single layer over its surface. The winding wire has a thickness of 0.2 millimeters. If the current of 5 ampere flow through the winding wire, what is the approximate value of the magnetic field at the mid plane of the solenoid winding on the axis? See, the wire is of thickness 0.2 millimeters. So if the wire is wound tightly, then the number of windings will be equals to the length of the solenoid divided by the thickness of the wire, right? So see here the diameter of the solenoid, the diameter of the wire which is wound is equals to 0.2 millimeters, and width of each turn is equals to 0.2 millimeters, right? So therefore the number of turns will be equals to is number of turns is equals to 1 upon 2 into 10 to the power of minus 4. So the number of turns is equals to 5000 turns in the solenoid, right? Now, therefore, the magnetic field in the solenoid is given by B is equals to mu naught into N into I. So, mu naught, putting the values mu naught, N is 5000, I is 5 ampere as given in the question. Finally, we get our B is equals to pi into 10 to the power of minus 2 Tesla. So, question number 11, the question number 11, correct answer is option number 4, that is pi into 10 to the power of minus 2 Tesla. So, the trick over here is was to calculate the number of turns. So, with the help of the number of, the thickness of the wire, the thickness of the wire, we can easily calculate the number of turns. The correct answer for question number 4. Now, a body A is dropped from the top of a tower. If another identical body B is projected horizontally from the same point at the same instant, then see what is being done over here is a body is being dropped. So here the initial velocity is equal to 0. Another body is thrown horizontally. In that case also the velocity in y-axis, you can write it as uy. Uy is equals to 0 in both the cases, right? Uy is 0 in both the cases. Acceleration is equals to g for both the cases. Displacement is the same height for both the cases. Therefore, both the bodies will reach the bottom at the same time. So the options, they say that both A and B will reach the ground simultaneously. Yes, so this is the answer. Let's see the other options also. A will reach the ground early. No. B will reach the ground earlier. No. Time for the fall depends on the match. No. So see, we can see that a ball has been dropped. So its initial velocity along y-axis, or the vertical velocity, initial velocity is equals to 0. When a body is being thrown horizontally, then its vertical velocity is again 0. So for both the bodies, we have velocity along y-axis initially is equals to 0, acceleration along y-axis is equals to g for both the cases, and displacement along y-axis for both the cases is equals to h. So in y-axis all the constants are same, therefore the time for travel will be the same, so both the bodies will reach the ground simultaneously. So the correct answer for this question is option number 12. Question number 12 is option 1. Now let's see question number 13. It says that a block of 10 kg, a 10 kg block is kept over 20 kg block as shown in the figure. Now the force F is equals to 2T is been applied on the 10 kg block. After what time 10 kg and 20 kg block will start moving separately? See, they will start moving separately when the force applied over here exceeds the static friction force between the two blocks. So the maximum force which could be applied is frictional force, that is F is equals to mg. So mu n is equals to mg. Mu is given as 0.2 and normal reaction force is equals to, normal reaction force will be equals to 10 into 10. So 10 into 10, and this is equals to m into g. M is equals to 20 into A, right? See, if I draw the free body diagram, this is for 10. Force applied will be equals to 2T, and here it will be the frictional force, and finally the body is moving here in this acceleration. And for 20 kgs, there is only one force acting over here, that is the frictional force, because it is on the smooth surface, right? So for this frictional force is equals to this frictional force, right? This is so from here we get Fs is equals to mg, and Fs is equals to mg, and Fs is also equals to mu into normal reaction force. So normal reaction force will be, because of this 10, so normal reaction force will be equals to 10 into 10. So from here we get mu into n is equals to, mu is given to us is 0.2. So 0.2 into 10 into 10 is the acceleration due to gravity, and this is equals to 20 into A. We got the value of friction, and this is moving with an acceleration A. So from here we get F friction Fr is equals to 20 into A. So what we are doing is, from this perspective of 10 kg, we are calculating the value of friction, that is equals to mu into mg, and that is equals to force on 20 kg, that is 20 into A. So from here we get A is equals to 1 meter per second square, right? Now if 10 kg have more than 1 meter per second square acceleration, there will have the relative motion. Means when the block of 10 kg has an acceleration more than 1 meter per second square, then both the blocks will move against each other, means they have a relative motion in them. So for 10 kg, from the free body diagram of 10 kg block, we can write the equation that Ft minus Fs is equals to m into A, that is 2T minus frictional force Fs is equals to m into A, right? This minus this is equals to m into A. So putting the values, Gt minus 20 Fs is equals to 20 as we calculated here, is equals to 20, and m into A is 1 meter per second square. So m is 10. So m into 1 is 10. So this is 2t, Gt, this is 2t. So we'll get 2t minus 20 is equals to 10. So we'll get your 2t is equals to 30. So t will be equals to 15 seconds, right? So t is equals to 15 seconds. Both the blocks will have a relative motion among them. So the correct answer for question number 13 is option number 2. Option 2, that is 15 seconds, right? Now let's get into question number 14. A capacitor of capacitance C is charged to a potential V from a cell and then disconnected from it. A charge Q is now given to its negative plate. The potential difference across the capacitor will be. So if the capacitor was charged to a volt V, then the charge on it is equals to CV, right? And the negative plate will be equals to minus CV. So if a positive plus Q charge has been given to it, then the new charges on the plate will be equals to, on the positive plate it will be CV, and on the negative plate it will be minus CV plus Q, right? Minus CV plus Q. So this implies that the potential difference between the two plates will be equals to the total charge upon the capacitance. So total charge will be equals to Q1 minus Q2 upon 2. Q1 minus Q2 upon 2 is charge on the positive plate minus charge on the negative plate upon 2. So V is equals to Q1 minus Q2 upon 2 into C. So from Q1 is C into V, and Q1 is C into V, that is charge on the positive plate, and Q2 is equals to minus CV plus Q. Putting the values, we get V is equals to V minus Q by 2 into C, right? So the correct answer for question number 14 is V minus Q by 2C. So that is in option number 2. So question number 14, correct answer is option number 2. Question number 15. Power given to the particle varies in the time as P is equals to 3t square plus 2t plus 6 watt. The change in the kinetic energy of the particle in first 3 seconds, change in the kinetic energy of the particle in first 3 seconds of its motion is, see, power is given to us in the as a function of time. So energy will be, when we integrate this power with respect to time, we'll get the energy. So what we have written over here is power is equals to dk by dt, that is the rate of change of kinetic energy is power. So dk will be equals to p dt. So integrating power will get the, we integrate, we get the kinetic energy as 54 joules, right? Simply integrating it, that is integrating 3t square plus 2t plus 6, 3t square plus 2t plus 6, and putting the limit from 0 to t limit as 0 to 3 seconds, right? So when you integrate p, we will get 3 into 3t cube plus 2t square upon 2 plus 6t, right? So sorry, this is upon 3. Now this 3 and 3 cancels out, this 2 and 2 cancels out. So what we are left with is t cube plus t square plus 6t. So we put the limit from 0 to 3, again here from 0 to 3, and again here limit from 0 to 3, and then if we calculate, the calculation has been done over here, and so we get the final kinetic energy as 54 joules. So the correct answer for question number 15 is option 4, that is 54 joules. So the basic concept used over here is that if power is given as a function of time, then if we integrate power with respect to time, the thing which we get is the energy, and in this case it was kinetic energy, right? So the correct answer for question number 15 is option number 4. Coming to question number 16. In a thermodynamic cycle process ABC, the internal energy at A is 10 joule and B is 70 joule. Heat given in the process B to C is 100 joule. Then heat released or absorbed in process C to A. Now, in the process ABC, we use delta Q is equals to delta U plus delta W. So delta U, that is the change in kinetic energy, sorry, change in the internal energy, will be equals to delta Q, that is the amount of the heat supplied, minus delta W, that is the amount of the work done. So from A to B, when we are moving from A to B, what we see is there is no change in pressure, but there is a change in volume. So definitely the work is being done. So putting the value, that is change in the energy, change in the energy. So change in the energy is at A it is 10 joule and at B is equals to 17 joule. So change in the internal energy from A to B, it is 60. So we have put 60 over here, is equals to delta Q, we need to calculate, and work done is equals to P dV. So P is 2 into 10 to the power of 5, and change in volume is equals to from 2 to 4. So it is 2 into 10 to the power of minus 3, right? Because in the graph we can see that it changes from 2 liters to 4 liters. So change in the volume is 2 liters. So change in liters means if we convert it into meter cube, it will be 2 into 10 to the power of minus 3 meter cube. So we have put the value over here as 2 into 10 to the power of minus 3 meter cube. So this is dV, that is change in the volume, and this is P, right? Solving this, we get 60 is equals to delta P minus 400. So delta Q is equals to 460, right? Delta Q is equals to 460. Now, moving from, hold on, in a thermodynamic cycle process, you see the internal energy is changed, the heat in the process. Alright, in this entire cyclic process, the change in internal energy will be equals to 0 because the initial and the final point will be the same. So, putting delta U is equals to 0, what we can say, the total exchange of energy will be equals to 0. So Q1 plus Q2 plus Q3 plus delta W is equals to 0. Why Q1 plus Q2 plus Q3 plus delta 1 is equals to 0? See, Q1 is the heat supplied during AB, Q2 is the heat supplied during BC, Q3 is your heat supplied during C to A, and this area is work done. The sum should be equals to 0 because the change in the kinetic energy is equals to, change in the internal energy is equals to 0 because it's a cyclic process. So Q1 we have calculated from here as 460, right? Q2 is given as 100 joules, that is we are moving from B to C, it is equals to 100 joules. So we put Q2 is equals to 100 joules. Moving from C to A, we are supposed to calculate. So Q1, Q3 is to be calculated. So we write Q3 as it is. Work done W is equals to, we just calculated from here, that is work done is equals to P dV, right? So putting P dV, and this is equals to 0. Solving this, we get Q3 is equals to 760 joule. Solving this, we get as 760 joule, and this will come as a negative. Q3 will come negative. So Q3 will be equals to minus 760 joule, right? Minus 760 joule. So if it is minus 760 joule, it means it is being released. So the correct answer for question number 16 will be option 2, that is 760 joule, right? I hope the solution is clear. What is happening over here is it is a cyclic process. So delta U is equals to 0, right? Delta U is equals to 0. We have in this entire process, heat has been supplied here from A to B, heat has been supplied from B to C, and there is a, or supplied, or you can say exchange of the heat, and there is an exchange of heat from C to A, right? And because of this, there will be some work done. That is, we are getting an area W here. So we are using, that is, Q1 plus Q2 plus Q3 plus W is equals to 0, right? So from this and putting the value, we get that heat released or absorbed during AC is equals to 760 joule. Question number 17. If mass of all gas molecules of a gas are halved and their speed are doubled, then the ratio of their initial and the final pressure will be. So we know the pressure is equals to 1 by 3 Nm upon V into C square. So from here we get that pressure is directly proportional to M into C square, right? Therefore, if mass is halved, mass is halved, pressure will be halved, and if C is doubled, that is the speed is being doubled, the pressure will become 4 times, right? So 4 upon 2 will finally result in 2. So the pressure will become double. So the ratio of initial pressure and final pressure will be equals to 1 is to 2. So the correct answer for question number 17 is 1 is to 2. 1 is to 2. That is option number 3. Question number 17, correct answer is option 3. Right? Now question number 18. 18. The magnetic flux phi is in a closed circuit of resistance 10 ohm varies with time. According to the equation, phi is equals to 60 square minus 5t plus 1. What is the magnitude of the induced current at t is equals to 0.25 seconds? See, phi is being given to us. So the induced EMF is equals to minus d phi by dt, right? So from here, if I differentiate phi, we'll get 6 into 2t minus 5, right? That is equals to 12t minus 5. So we get induced EMF as 12t minus 5. So because we have a minus sign also here, it will become 5 minus 12t. This is the induced EMF, right? Now the current I is equals to E upon R. So we have E as 5 minus 12t, and we have t is equals to 0.25. Putting the value, we get E is equals to 5 minus 3, which is equals to 2 volt, and the resistance given to us is 10 ohm. So the current I will be equals to V by R, that is 2 upon 10, which is equals to 0.2 ampere. So the correct answer for question number 18 will be option 4, that is 0.2 ampere, right? So the basic concept here was differentiating phi as a function of time. We'll get the induced EMF, and once we have the induced EMF, dividing it with the resistance will give you the current. Question number 18 is done. Question number 19. Question number 19 says, if velocity velocity p, acceleration q, and density r are taken as a fundamental quantities, then the dimensional formula for kinetic energy is. So if velocity p, then the dimension of p will be equals to L t minus 1. Acceleration is q, that is L t minus 2, and dimension of density is equals to ml cube. So we need to find the relation between kinetic energy and PQR. So what we have done is that kinetic energy is equals to P raised to the power of A, Q raised to the power of B, and R raised to the power of C. Now putting the dimensions of all the four quantities, that is the kinetic energy, the velocity, the acceleration and the density, will get ml square t minus 2. This is the dimension of kinetic energy, is equals to velocity raised to the power of a, then this is your acceleration raised to the power of b, and then this is your density raised to the power of c. Putting the concept of the exponents, that is rearranging the powers and solving it, we get the value of c is equals to 1, c is equals to 1, b is equals to 8, and a is equals to a is equals to, let's do it. See, what we have is m l square p minus 2, right? This is kinetic energy, is equals to velocity l p minus 1 raised to the power of a into your acceleration l p minus 2 raised to the power of b into m l minus 3 raised to the power of c, right? From here we will get m l p ml square p minus 2 is equals to m raised to the power of c l raised to the power of a plus b, a plus b minus 3c, and p raised to the power of minus a minus 2b, minus a minus 2b, right? Now comparing the powers, we get c is equals to 1, a plus b minus 2c is equals to 2. So we'll get, putting c is equals to 1, we'll get a plus b is equals to 5, right? A plus b is equals to 5, and from this, for power t, minus a minus 2b is equals to minus 2, that is a plus 2b is equals to 2. Therefore solving the above, we have the equation a plus b is equals to 5 and a plus 2b is equals to 2. Subtracting this will go, this minus b is equals to 3, so b is equals to minus 3. Putting b is equals to minus 3, we'll get a is equals to 8. So we have a is equals to 8, b is equals to minus 3, and c is equals to 1. So we get a is equals to p raised to the power of a, so p will be raised to the power of 8. Q was raised to the power of b, so q will be raised to the power of minus 3, and r was raised to the power of c, so we have c as 1, so r will be raised to the power of 1. So k will be equals to p raised to the power of 8, q raised to the power of minus 3, r raised to the power of 1. So according to this, the correct answer for this question will be equals to 8 minus 3 1. 8, 8, 8 minus 3 1. Correct answer is option number 4. The correct answer for question number 19 is option number 4. This was using dimensional analysis. Now heat required to convert 10 gram of ice at 10 degree centigrade to water at 20 degree centigrade is, alright, moving from minus 10 degree centigrades to 0 degree centigrades, there will be a change of state. So we will write it as 10 into change in temperature will be of, see, what is happening is the ice is moving from minus 10 degree centigrade to 20 degree centigrade water. So what all the phases will be there, from minus 10 degree centigrades to 0 degree centigrades, it is ice. Then second thing will be from 0 degrees ice to 0 degrees water, and the third phase will be from 0 degrees 0 degrees water to your 20 degrees water, right? So for this first part, there is a change in state, So we will apply Q is to mc delta T. For this second, from where ice is converting into water, we will Q2 is equals to M. And for the third phase at 0 degree centigrade is rising centigrade will equals to again mc T. So the water is converting from, so if mass is equal to 10 gram and specific heat capacity of ice is 0.5 calorie per gram per degree centigrade, so putting mc delta T will get 50 calories, right? This is our Q1 as I explained. This is for the first phase. Now when the change of state in the ice is taking, so it will be equals to m into L. So m is 10 grams and L is 80 calorie per gram. That is the latent heat of fusion of ice. So it will be equals to 800 calories, which is equals to your Q2. Right now the ice will convert to water. So mc delta T, mass is 10 gram. Change in temperature is from 20 to 0 to 20, so it is 20, and your specific heat capacity of water is 1 calorie. So putting this value, we get your Q3 is equals to 200. This is Q3. The total heat supplied will be equals to Q1 plus Q2 plus Q3. That is 800 plus 200 plus 50. So it will equals to 1050 calories. So the correct answer for question number 20 is 1050 calories. So again, in this question, there are three phases taking place. One, that is first the water ice at minus 10 degree centigrade is converting into ice at 0 degree centigrade. For that, the heat supplied is Q1. Then the ice at 0 degree centigrade is converting into water at 0 degree centigrade. That is a change in the phase. So we'll use ml as the formula, that is mass into latent heat, and this is the heat supplied is equals to Q2. And then water at 0 degree centigrade is converted into water into 20 degree centigrade. Here the change in temperature takes place. So we'll use mc delta T, and this heat supplied is taken as Q3. The total heat supplied will be equals to Q1 plus Q2 plus Q3. Right? Correct answer for question number 20 is 1050. Question number 21. Now, if a particle is projected with a velocity u so that its horizontal range is thrice the greatest height attained, then the horizontal range is. Simply they are saying that if in a projectile motion r is equals to 3 times of h. We know the formula for r is equals to u square sine 2 theta upon g. H is equals to u square sine square theta upon 2g. Putting these values of r and h in this first equation, we get this, and solving this, we get cot theta is equals to 3 by 4. Right? Now, if cot theta is equals to 3 by 4, what is cot theta? Cot theta is equals to base upon perpendicular. So, for base upon perpendicular, so we have base is equals to 3, perpendicular is equals to 4. We will have hypotenuse is equals to 5. Right? So, from here we can say sin theta is equals to 4 by 5 and cos theta is equals to 3 by 5. So, we use the formula of range r is equals to u square 2 sin theta cos theta upon g. How we have done this? We have the formula r is equals to u square sin 2 theta upon g. So sin 2 theta can be written as 2 sin theta cos theta, right? So doing the same, what we get, r is equals to u square 2 sin theta cos theta upon g. We have the value of sin theta and cos theta. Putting these values of sin theta and cos theta and calculating, we get r is equals to 24 u square upon 25, right? So the range will be equals to 24 u square upon 25, which is in your option 1, right? 24 u square upon 25. G is the correct answer for question number 21, that is option number 1. Simply it is again a formula based question. So the answer for question number 21 is your option 1. Question number 22. A bar magnet hung by an insulating thread of a uniform horizontal magnetic field and in a uniform horizontal magnetic field and magnet is in equilibrium initially. Okay, the torque required to keep the magnet at angle of 30 degree with the direction of the magnetic field is tau. Then the work done to rotate the same angle from initial portion. See, tau is given by mb sin theta, that is the torque on a magnet is given as mb sin theta. Now when the magnet is when the magnet 30 degree magnet is to be rotated at angle of 30 degree, the torque will be equals to, we will put theta is equals to 30, so tau will be equals to mg sin 30, that is equals to mb upon 2, because sin 30 is equals to 1 upon 2, right? What from here we get mb is equals to 2 tau, right? So this is the first equation. Now work done when the magnet is rotated by 30 degree, work done is equals to mb cos theta 2 minus cos theta 1, where theta is the final, theta 2 is the final between M and B, and theta 1 is the initial angle between M and B. So when, see, when the magnet is being suspended, it is in equilibrium. Equilibrium means the angle between M and B, that is the magnetic dipole moment of the magnet and the magnetic field, external magnetic field, is equals to 0, right? So theta 1 will be taken as 0, right? And then we need to place the magnet at an angle of 30 degree. So theta 2 will be taken as 30 degree, and we have mb as 2 tau. So putting mb as 2 tau, cos theta 2 is cos 30 minus cos theta 1 is cos 0. Putting the values when we calculate, we get work done is equals to W is equals to tau into 2 minus root 3. So according to this calculation, the correct answer for question number 22 will be option number 1, that is 2 minus root 3 into tau, right? So the correct answer for question number 22 is option number 1. A cyclist paddling at a speed of 10 meter per second on a level road takes a sharp circular turn of radius 10 meter without reducing the speed. The angle made by the cyclist with the vertical is, see, when this is related to circular motion, and when there is a turn without reducing the speed, we use the formula used in the banking of road, that is tan theta is equals to v square upon rg, right? V square upon rg. V is being given to us as 10 meter per second, r is being given to us as 10 meters, and g will take it as 10. Putting these values, we get tan theta is equals to 1, so theta will be equals to 45 degrees, right? Again, simply the formula with the question, that is tan theta, the angle of banking, tan theta will be equals to v square upon rg. So the correct answer for question number 23 is 45 degrees, is pi by 4. So correct answer is option 1, pi by 4. Now let's come to question number 24. Question number 24 says that as given in the figure, a series circuit connected across 200 volt 60 hertz line consisting of a capacitor of a capacitive inductance 30 ohms and non-inductive resistor of 44 ohm and a coil of inductive reactance 90 ohm and resistance 36 ohm. And the power dissipated in the coil is, so power dissipated in the coil on AC circuit, LCR circuit, we is give power as P is equals to I RMS square into R, and I RMS is equals to V RMS upon Z, where Z is the impedance of the circuit. Now V RMS is being given to us as 200 volts in the question. What about the Z? So Z is equals to under root of R square plus XL minus XC whole square, right? In the question, they have given us that XC is equals to 30 ohm. This is XC. XC is equals to 30 ohm, and your XL inductive reactance is 90 ohm. XL is equals to 90 ohms. Resistance, if we talk about resistance R, so resistance R will be equals to your 44 ohm plus 36 ohm in series, so this will be equals to your 80 ohms. right? Putting these values here, we'll get impedance Z is equals to under root of 6400 plus XL minus XC is your 60, so it will be 3600. 3600, so this is equals to 10,000, so the root will be equals to 100. So impedance comes as 100. Putting impedance as 100 here, we'll get IRM is equals to 2 ampere. So IRM is equals to 2 ampere. So P is equals to IRMS square into R. So P is equals to IRMS is 2 square into R is 36. We get power as 144 watt. So the correct answer for question number 24 is 144 watt, that is option number 3. The correct answer is 144 watt. Question number 25. Now question number 25 says the magnetic moment produced in a substance of 1 gram is 6 into 10 to the power of minus 7 ampere meter square. If its density is 5 grams per centimeter cube, then the intensity of magnetization A by M in ampere per meter will be. So intensity of magnetization is given by I is equals to M upon V, where M is the magnetization, V is the volume, right? So given mass is equals to 1 gram, so mass will be equal to 10 to the power of minus 3 kg. Density is being given as 5 gram per centimeter cube, so it will be 5 into 10 to the power of minus 10 to the power of 3 kg per meter cube, right? So putting the so we have density, we have mass, from here we'll get the volume. So we know that density is equals to mass upon volume. So volume is equals to mass upon density. So here mass is being given to us is 10 to the power of minus 3 and density is equals to 5 into 10 to the power of 3, right? Putting this value of volume in the equation, I is equals to M upon V, and solving it, we get I is equals to 3 ampere per meter. So the correct answer for question number 25 is option 2, that is 3.0. Now let's come to question number 26. So now let's get into question number 26. So question number 26 says that the velocity time graph of a particle moving in a straight line along the positive x-axis is as shown in the figure, and at t is equals to 0, x is equals to minus 10 meters. So the maximum value of the position coordinate is 50, 70, 60 or 80. So maximum value position coordinate will be given at the positive displacement, and in the graph you see that for first 24 seconds the velocity is positive, so the displacement will be positive, and after 24 seconds the displacement velocity is negative, so the displacement will be negative, right? So if we calculate the displacement in first 24 seconds, we can get the answer. So to calculate the displacement, we'll have to calculate the area under the curve of a velocity time graph. So we'll divide this total area into some parts. First part will be this triangle, second part will be rectangle, and then second part will be this rectangle, and the third part will be this triangle, and the fourth part will be this triangle, right? So just for the clarity, for the first part, this we have base is equals to 10 and height is equals to 2, it comes to be 20. Now the second part, that is this rectangle, we have base as 8 and height as 2, so it will be equals to 16. Now for the triangle, this triangle base as 8 and height as 4, so it will be equals to half into base into height is equals to 16. Height is 4, 16. So again plus 16, right? And then for the fourth triangle, that is base is 6, height is 6. So 6 6 are 36 and 36 by 2 is 18. So this will give you equals to 70 meter, right? But initially it is at minus 10. So we'll subtract 10 out of it, we'll get 60. So the maximum positional coordinate is of 60 meters. So the correct answer for question 26 is option 3, that is the maximum value of the positional coordinate is 60 meters, right? We simply calculate total displacement in the positive direction by calculating the area under the curve, which is coming as 70 meters, and because initial position was minus 10 meters, therefore the maximum value of position coordinate marked could be 70 minus 10, which is equals to 60, that is equals to 60 meters, right? Now let's come to question number 27. Question number 27. Question number 27 says the capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of resulting system is. So initially let C1 is equals to C, then V1 is equals to V, right? So here the energy E1 will be equals to half C V square. Now a capacitor of identical capacitor has been connected to it, so the common potential V dash will be equals to uh, see another capacitor is uncharged, so its voltage will be 0. So using the value formula C1 V1 plus C2 V2 upon C1 plus C2. Now putting the values, we get common potential V dash is equals to C1 is C, V1 is V, plus C2 is C, but V2 is 0, so it will be 0 upon C1 plus C2 is 2 times of C. So from here we get that common potential of the combination V dash will be equals to V by 2. So energy E2 will be equals to half C is 2C because they are connected in parallel, and V by 2 whole square. So this would result in half into 2C into V square upon 4, right? So this will be equals to 1, 2, so we can write it as half of half CV square. So what we can write from here is, this is E2. So what we can say that E2 is equals to half of E1. So from here we can say that the energy is reduced by a factor of 2. So energy is reduced by a factor of 2 is being given in option 2, that is the resulting energy is decreased by a factor of 2. So the correct answer in question number 27 is option 2, right? Now let's come to question number 28. An ideal gas at 27 degrees centigrade is compressed adiabatically at 8 by 8 by 27 of its original volume. If gamma is equals to 5 by 3, then the rise in the temperature is. Okay, for an adiabatic process, the equation we use is Tv raised to the power of gamma minus 1, and it is a constant. So from here we can say that T2 upon T1 is equals to V1 upon V2 raised to the power of gamma minus 1. Why? Because from here we can say that T is inversely proportional to V raised to the power of gamma minus 1. So from here we can say that T1 upon T2 is equals to V2 upon V1 whole raised to the power of gamma minus 1. Right? So we have T1 as 27 degrees centigrade, so in Kelvin it will be 300 Kelvin. Now if we take the initial volume of the gas as V1 and the final volume is V2, so V2 will be equals to 8 by 27 of V1 as given in the question, right? Now putting these values and calculating, we get T2 is equals to 675 Kelvin, and then this will be equals to T2 is equals to 675 Kelvin, and T1 is equals to 300 Kelvin. So the rise in temperature will be equals to 375 Kelvin, right? 375 Kelvin. This is the change in temperature, or you can say the rise in temperature. So the correct answer for question number 28 is 375 Kelvin. That is option 1, right? Now let's see question number 29. Question number 29, a car battery of EMF 12 volt and internal resistance 5 in 10 to the power of minus 2 ohm receives a current of 60 amperes from external source. Then the terminal potential difference of battery is. So this is the case of charging, right? This is a case of charging. They are receiving. 12 volt, internal resistance now receives a current of 60. It is receiving a current na, so it is a case of charging. Oh, so in the case of charging we use V is equals to E plus I into small r, right? So V is equals to, they are asking the terminal potential difference, that is V they are asking. E is being given to us as 12 plus I is 60 into R is 5 into 10 to the power of minus 10 to the power of minus 2, right? So this is equals to 12 plus this will be equals to 3, it is equals to 15 volt, right? So the correct answer for question number 29 is 15 volt, that is option 3. Option 3 is the correct answer, that is 15 volt. Now let's get into question number 30. Question number 30 says that the reading of an AC voltmeter in a network shown in the figure we need to calculate this V, that is the potential drop across the capacitor, right? Now in this question from the figure we can see that XC is equals to XL. So calculating the impedance, we have impedance Z is equals to under root of R square plus XL minus XC का whole square. So impedance will be equals to R. So impedance will be equals to R. So R over here is, R is 11 plus 11 is 22. So R is equals to 22 ohms. Right. Now from this we can say that this is V naught. So V naught is equals to 220 root 2. So from here we can calculate VRMS. VRMS is equals to V naught upon root 2. So it will be equals to 220 volts. We have VRMS with us. We have VRMS with us. So IRMS will be equals to VRMS upon Z upon Z. So this will be equals to 220 upon Z is nothing but R, which is equals to 22. So we get IRMS is equals to 10 ampere, right? Now if IRMS is equals to 10 ampere, so voltage drop across the capacitor will be equals to IRMS into XC. So IRMS is equals to how much? 10 ampere into XC is how much? 20. So it will be equals to 200 volt. So the correct answer is 200 volts. So question number 30 answer is 200 volt. That is option 3. So the correct answer for this question option 30 is option number 3. Right. Now question number 31. The magnetic field B and the magnetic intensity H in an material are found to be 1.6 Tesla and 100 ampere per meter respectively. Calculate the relative permittivity mu R and the susceptibility for the material. So relative permittivity mu R, wait a minute, mu is given to as B by H. So B by H means it will be equals to 1.6 upon H is 1000. So it will be equals to 1.6 into 10 to the power of minus 3. Right. Now mu R is equals to mu upon mu naught. Right. So this will be equals to 1.6 into 10 to the power of minus 3 upon mu naught is 4 pi into 10 to the power of minus 7. So we will get mu R is equals to, calculating this, here we have done mu R will be equals to 0.127 into 10 to the power of 4. So we will finally get mu R is equals to 1.3 into 10 to the power of 3. Right. This is your mu R. and then we have to calculate successibility. To calculate successibility, we have the formula mu is equals to mu naught into 1 plus xi. So putting the value and calculate, we get xi is equals to 1.3 into 10 to the power of 3 approximately. So we get the value of mu and successibility almost the same. So the correct answer for question number 31 is 1.3 10 to the power of 3 each. 1.3 into 10 to the power of 3 each. So option 2 is the correct answer. So the formula used over here is mu is equals to B by H, mu R is equals to mu upon mu naught, and mu is equals to mu naught into 1 plus xi. Right? So using these three formula, we get that magnetic susceptibility and permeability, relative permeability is same, that is 1.3 into 10 to the power of 6. Then question number 32. A copper wire have length L and area cross section as three copper wires L A 2 L and A by 2 and L by 2 and A. So from here we can say the volume for all the wires are same. If the volume for all the wires are same, we can say that from here to here the wire is stretched to a length of double of its length. So here the factor of stretching is equals to 2. Then from here to here we can say that the wire is compressed to half of its length. So the factor is equals to 1 by 2. Why factor? Because if you remember the formula, that new resistance R dash is equals to N square of R. N square of R means this is the case when a wire is being stretched to a new length, then the resistance changes by this factor. That is, new resistance will be equals to the factor by which the length is being changed is N. So N square by R will be the new resistance, right? So what we find that if the initial length is L and final length is 2L in the second case, it means the length is made double. So the new resistance will be 4R. So for this, for the first wire, if the resistance is R, for the second wire the resistance will be equals to 4R. Now in the third wire the length is made half, means keeping the volume length is made half, it means the wire is being compressed, so the thickness will be more. Now the thickness will be more, so for the factor here with which the length is being changing is 1 by 2. So the new resistance will be equals to 1 by 4 times. So for the third wire resistance will be equals to R by 4. R by 4. So what they are asking here is the three copper wire have the length and cross sectional areas as this. The resistance is minimum in the third wire. So the wire of the cross section area 2A. Yes. So option 1 is the correct answer. Wire of cross section area A by 2, no. For A by 2 we have resistance as 4R, and then the wire of cross section area A we have resistance as R. Same in all now. So the minimum resistance will be in the wire which is being compressed, that is we have reduced the length and increased the area. So the resistance will be minimum, right? So this formula is being used over here where new resistance is equals to N square into R, where N is the factor by which the length is being changed of the wire. The length of the wire is being changed without changing the volume, right? That is for the case when the wire is being stretched. So the correct answer for question number 32 is option A, that is option 1. Let's come to question number 33. Question number 33 says that find the double derivative of y is equals to a. So differentiating it first, that is dy by dx will be equals to 3x square minus 2x plus 1. Now differentiating it again, d2y upon dx square will be equals to 6x minus 2. So the correct answer will be 6x minus 2, that is 6x minus 2, option 2, right? Now let's get into question number 34. Question number 34. Particle P strikes an inclined smooth plane horizontally and rebound vertically as shown in the figure, right? If the angle theta is 60 degree, then the coefficient of restitution is, that is they are asking the value of E. So the particle P strikes the inclined smooth plane horizontally and revolved vertically, shown in the figure. The angle theta is 60 degrees. So this is 60 degrees. This angle is equal to 60 degrees. And then the coefficient of restitution they are asking. So if initial velocity is u of the particle before collision and the velocity of the particle after collision, what will happen? The restitution of the velocity of the particle, we have resolved the velocities. What will happen? This is u and this is v, right? Now this u can be resolved like this is v and one component is this, right? And if this is u, one, let me draw it again. See, if this is the plane, this is the inclined plane, this angle is given to us as 60 degree. Now u is this, this is u, so we can extend u like this. Now if we resolve this u along the plane and perpendicular to the plane, right? This angle, if this is 60, this will be 60 alternate angles, and if this is 60, this will also be 60. So this will become u cos 60 and this will be equal to u sin 60. It is rebounding in this direction, vertical. So if this is v, now if this is 60, this is 60, this will be equal to 30. So when resolve v along the plane, we get v is equals to v cos 30 and perpendicular to the plane. So it will be perpendicular to the plane like this, and this will be equals to v sin 30, right? V sin 30. Now as the plane is smooth, there is no force exerted on the inclined plane by the inclined plane on the particle along the horizontal axis, that is inclined plane. So the velocity of the particle does not changes along the plane, that is v cos theta is equals to u cos theta. Because the plane is smooth, so there will be no change in the velocity along the plane, means there will be no change in the velocity along this. So v cos 60 will, sorry, u cos 60 will be equals to v cos 30. So we have u cos 60 is equals to v cos 30, right? So u by 2 is equals to root 3 times of v by 2. So 2 goes off, we get u is equals to root 3 times of v, right? Now coefficient of restitution along the among the common normal. Now if we talk about the normal, this normal of the plane, we have v2 minus v upon u1 minus u2. So v2 is, that is the final velocity, that v sin 30, right? This v sin 30 minus, initially it was 0, there was no velocity in the vertical direction. Then there is no change in the initial horizontal initial velocity. So u1 is equals to 0 and u2 is equals to minus 60 minus u sin 60. Why minus? Because u sin 60 in opposite direction of v. So putting these values and calculating, we get your E is equals to 1 by 3. V2 is equals to V sin 30. V1 is equals to 0 because there was no initial vertical velocities, right? And U1 is equals to 0 minus U2 is equals to minus U60. Putting this value, we get E is equals to 1 by 3. So the correct answer for this question is 1 by 3. So answer option 2 is equals to 1 by 3. Question number 35. Question number 35 says, question number 35 says that the temperature of an ideal gas, the temperature of an ideal gas increase from 10 Kelvin to 400, sorry, 100 Kelvin to 400 Kelvin. Now, if root mean square speed of the gas at 100, then the root speed of the gas will be. Now, initial temperature is 100 Kelvin, final temperature is 400 Kelvin, RMS speed at 100 Kelvin is V, then RMS speed at 400 Kelvin V2. RMS speed is given by under root 3T by M. It means VRMS directly proportional to the root of T. So from this we can write V1 upon equals to under root of T1 upon T2. So V1 upon T2 equals to 1 by 2. So if made 4 times, the velocity will, so the number 35 will be equals to option 2, that is 2V. Right? Now let's come to question number 36. Question number 36. In a series LCR circuit, R is equals to 10 ohm is equals to 14, XL is equals to power factor of the circuit. For we can use the impedance triangle. Triangle say that this is phi, this is Z, R, and this is XL difference T, and power cos phi. So cos phi will be equals to base upon hypotenuse, that is R upon Z, right? So according to the data given in the question, Z will be equals to is equals to under root of R square plus XL minus XC whole square. So this is equals to under root of R square is 100 plus XL minus XC is 10. 10 ka square is again 100. So this will be equals to 10 root 2. Z is equals to 10 root 2 and R is 10. So cos phi will be equals to, so cos phi will be equals to R upon Z is 10 root 2. This goes off and we get is equals to 1 by root 2. So power factor is equals to 1 by root 2. So the correct answer of question number 36 is option number 36 is option 3, that is 1 by root 2, right? So now let's get into question number 37. So question number 37 says that a galvanometer having a resistance of 8 ohm is shunted by a wire of resistance 2 ohm. If the total current is 1 ampere, the part of it passing through the shunt will be. So if we draw the diagram for a galvanometer which is converted into a meter is like this. So the total current is I and the current get distributed as Ig, which is going into the galvanometer, and Is is going into the shunt S, right? So because galvanometer and the shunt are connected in parallel, we can say the potential drop across galvanometer and the shunt is equal. So we can say that Ig into G, where G is the resistance of the galvanometer, is equals to Is into S, right? Now we have to find the part of passing the shunt. We have to find Is. So Is is not known to us, so we can write Is. So Ig. Alright, Ig can be written as I minus Is into G is equals to Is into S. Right? Now from here what we can say is I into G minus Is into G is equals to Is into S. From here we can say that I into G is equals to Is into S plus G. So Is will be equals to I into G upon S plus G. So current going in the shunt will be equals to 1 into 8 upon 10, which is equals to 0.8 amperes, right? So the correct answer for question number 37 is option 2, that is 0.8 amperes. Question number 38. Question number 38 says that the magnetic field at the center of a circular loop of area A is B. The magnetic moment of the loop is. So let R be the radius of the circular loop. Area is equals to pi r square. So R is equals to under root A upon pi. Now the magnetic field at the center of the loop is given by mu naught I upon 2R. Right. So putting the values of B will get mu naught into I upon 2R is under root A upon pi. So I, from here if we calculate I will be equals to 2B upon mu under root A upon pi, right? Now we got the value of I. Magnetic moment M is given as I into A. So putting the values I is as 2B upon mu under root I upon pi into A. Solving this will get M is equals to 2BA under root A upon mu naught under root pi, which is in option 4. So the correct answer for question number 38 is option 4, right? Now question number 39. Question number 39 says that if two bulbs whose resistance are in the ratio 1 is to 2 are connected in series, the power dissipated in them are in the ratio. So the resistances are connected in series. We can read all the circuit like this. See, two bulbs, they are connected in series, right? So current through them will be I. If this is R, then this is 2R according to the question. So they are asking the power dissipated in them. Power dissipated in first resistance will be square R, and power dissipated in second resistance will be equals to I square into 2R, which is equals to 2 times of I square R. So from here we can say that P1 upon P2 is equals to 1 is to 2. So the correct answer for this question number 39 is option 4, that is equals to 1 is to 2, because in the first resistance we can say that the power dissipated is equals to I square R, and the second it is 2 times of I square R, right? So the power ratio will be also equals to 1 is to 2. So the correct answer for question number 39 is option 4. Now question number 40. Question number 40 says that if H1 and H2 are the greatest height of the projectile in two paths for a given value of range, then the horizontal range of projectile is given by. Okay. So in this what we have to use the concept is that R for theta is equals to R for 90 minus theta, right? R for theta is equals to R for 90 minus theta. That is range for an angle. Theta is equals to a range for its complementary angle. This is true, right? So if there are, we have the formula for maximum height is equals to H is equals to U square sine square theta upon 2G. So H1 will be equals to for theta and H2 will be for 90 minus theta. So H1 is equals to U square sine square theta 1 upon 2G, and H2 will be equals to U square sine square theta 2 upon 2G, right? Now solve, when we are multiplying this, we will get H1 into H2 is equals to U raised to the power of 4 sine square theta 1 into sine square theta 2 upon 4 G square. Now H1 into H2 is equals to sine raised to the power of 4 U raised to the power of 4 sine square theta 1 sine square theta 2 is written as 90 minus theta 1 upon 4G square, right? So H1 into H2 is equals to U raised to the power of 4 sine square theta 1 into sine 90 minus theta can be written as cos theta. So we write it as cos square theta 1 upon 4G square. So H1 into H2 will further be written as your U raised to the power of 4 4 sine square theta into cos square theta upon 16. So let me write it from here. It says that now H1 into H2 is equals to u raised to the power of 4 into sine square theta plus sine square theta into cos square theta upon sine square theta cos square theta upon 16g square, right? So sorry, 16 4g square is 4g square. Now we are multiplying with 4 upon 4 on both the, multiplying with 4 upon 4, we get h1 into h2 is equals to u raised to the power of 4 into 4 sine square theta into cos square theta upon 16 g square, right? So what we can write it further is u raised to the power of 4 into 2 sine theta cos theta whole square upon 16 g square, right? Why? Because this is 4 sine theta cos theta. So 4 can be written as 2 sine square theta can be written as sine theta, cos square theta can be written as cos theta, and the whole square. Now this 2 sine theta cos theta can be written as sine 2 theta. It's a trigonometric identity. So this will be equals to your u raised to the power of 4 into sine 2 theta square. So it will become sine square 2 theta upon 16g square. So this is what h1 into h2. So from here we get h1 into h2 is equals to u raised to the power of 4 sine square 2 theta upon 16 g square, right? Now range r is equals to u square sine 2 theta 1 upon g. So r1 range is same, so r square will be squaring both the sides, will get r square will be equals to u raised to the power of 4 sine square 2 theta upon g square, right? So now dividing this r square and h1 into h2, what we get h1 upon h1 into h2 upon r square is equals to 1 upon 16. So h1 into h2 is equals to r square upon 16. So we get r is equals to 4 root of h1 into h2. So from here we can say that the correct answer for this question 40 is option 3, right? Option 3. So now let's get into question number 41. Question number 41. Two charges Q1 and Q2 are distance apart. The ratio of electrostatic force acting on them will be 1 is to 1. Why 1 is to 1? Because according to the Coulomb's law, the force on two charges kept at a separation r is given by F is equals to 1 by 4 pi epsilon naught Q1 Q2 upon r square, and they are equal and opposite on both the charges. So they are equal in magnitude, so the ratio will be equals to 1 is to 1. So the correct answer for question number 41 is option 1, option 4. Now let's get into question number 42. It says that the pressure of a gas changes linearly with volume from P to Q as shown in the figure. Alright. If no heat is supplied or to or extracted from the gas, that is there is no heat exchange, the change in the internal energy of the gas is. Alright, so this is the graph being given to us. So in this process there is no heat supply, so delta Q is equals to 0. We have the equation that is delta Q is equals to delta U plus W. So putting delta Q equals to 0, we get 0 is equals to delta U plus delta W. Now in the graph, W is equals to area of the trapezium, that is area of this trapezium is coming out as minus 6 joule. So it is coming as minus 6 joule. So we have work done is equals to minus 6 joule. Now from this equation we can say that delta U is equals to minus of delta W. Putting the value of minus delta W over here, look at delta U is equals to plus 6 joule. So the change in internal energy of the system will be equals to plus 6 joule. So the correct answer for question number 42 is option 2. Question number 43. Question 43 says that a coil of resistance 400 ohm is placed in a magnetic field of magnetic flux phi Weber. Linked with the coil varies at time is equals to time as 50 t square plus 4. The current in the coil at t is equals to 2 seconds is. Now flux is being given to us as 50 t square plus 4. Now phi is equals to phi as a function of time is been given as 50 t square plus 4. So EMF induced is equals to minus d phi by dt. So this will be equals to minus 10 t, right? So at t is equals to 2 seconds, E at t is equals to 2 will be equals to minus 20 volts. Minus 20 volts. Now if E is equals to minus 20 volts and the resistance is equals to 400 ohm, oh sorry, it's 50, no? It's 50. It's 50, so it becomes 100, and if it is 100, so it becomes 200 volts. So EMF induced has a magnitude of 200 volt, and the resistance is equals to how much? 400. So the current will be equal to 0.5 years, right? So the correct answer for question number 43 is 0.5 ampere. That is option 3, right? Now let's get into question number 44. A force F is applied on a square area of side L. The percentage error in the measurement of L is 2% and that in F is 4%. Now what is the maximum percentage error in the pressure? So pressure is equals to force upon area. So percentage error in pressure will be equals to percentage error in force plus percentage error in length whole into 2, right? Why? Because area is L square, so the percentage error will be multiplied with 2 and then added. So percentage error in pressure will be equals to 4 plus 2 into 2, which is equals to 8%, right? So the correct answer for question number 44 is option 4, that is 8%, right? Pressure is equals to force upon area. So and area is equals to L square. So percentage error in pressure will be equals to percentage error in force plus 2 times the percentage error in length. So percentage error in force is 4 and percentage error in length is equals to 2. So 4 plus 2 into 2 is 8%. So correct answer for question number 44 is option number 4, that is 8%. Now question number 45. Question number 45 says that a current of 10 ampere is maintained in a conductor of cross-sectional area 1 centimeter. If the free electron density of the conductor is 9 × 10 to the power of 28 meter per meter cube, the drift velocity of the free electron is. So for this we will use the relation I is equals to NEA VD, and from here we can say that VD is equals to I upon NEA, where I is the current, N is the free electron density, E is the charge, that is 1.6 10 to the power of minus 19, and A is the area of cross section. Area of cross section is given to us as 1 centimeter square. It could be converted into meter square and then put the value. E is equals to 1.6 10 to the power of minus 19. N is being given to us as 9 into 10 to the power of 28, right? And I is being given to us as 10 ampere. So putting all these values and calculating for VD, we get VD, that is drift velocity, is equals to 6.94 into 10 to the power of minus 6 meter per second. So the correct answer for question number 45 is option 4. Again, it is direct formula based question. We have the formula here, that is VD is equals to I upon NEA. Simply put the values with the correct units, you will get the answer. Question number 46. Question number 46 says that the speed of the light in SI system is 3 into 10 to the power of 8 meter per second. new system, the unit of light is in kilometer and unit of time is in b seconds. The speed of light in the new system will be. So using n1 into u1 is equals to n2 into u2, that is numeric value in first system into unit of first system is equals to numeric value of second system is equals to unit of second system, right? So numeric value is first system is 3 into 10 to the power of 8 and unit is meter per second is equals to numeric value of second unit we have to calculate, and unit is a kilometer per br, right? Sorry, b seconds, b seconds, a kilometer per b seconds. Okay, now this can be written as 3 into 10 to the power of 8 meter per second is equals to n2 into a into 1000 meter upon b seconds. So seconds, meter per second, meter per second cancels out. So what we are left with is n2 is equals to 3 into 10 to the power of 8 into b by a into 10 to the power of 3. 10 to the power of 3 makes it 10 to the power of 5. What we are left finally is n2 is equals to b by a into 3 into 10 to the power of 5. So 3b by a into 10 to the power of 5, 3b by a to the power of 5 is in option 4. So correct answer for question number 46 is option 4, right? Now question number 47. The charge Q is placed at the center of a line joining two exactly equal positive charge. This Q, the system of the three charges will be in equilibrium if Q is. So what has been done over here is that here are two charges. This is Q and this is also Q, two exactly equal positive charge, right? And at the center of these two charges, a Q is being placed. They are asking you what should be the value of the small q so that the system is in equilibrium. So system will be in equilibrium when, see, this q, this plus this q is repelling this q with a force, let's say F1. So for equilibrium, the net force on the body should be equals to 0. So to make net force on the body to be 0, the another force should be acting in this direction. And this force is because of small q. So let it be F2. Now same will be the scenario with this because the system is symmetrical. So if we find F1 and F2 and they equate to each other because they for the system to be equilibrium they have to be equal opposite, we can get the value of q, right? If we talk about small q, this q will be repelling it in this direction and this q will also be repelling in with this direction. The distance is same, charges involved are same, therefore the net force on small q will be 0. We can see it from here. But to find for what value of small q the net force on capital Q will be 0, we will have to equate the two forces. So from here we can say F1 is equals to K Q square upon R square when the distance between them is R, right? And on the other hand, F2 will be equals to K Q into small q upon R by 2 whole square. So from here we can say that F2 is equals to K by 4K Q into Q upon R square. Equating these two, here we are equating that is K q upon r square is equals to k q square upon 4r square, and solving it we get small q is equals to minus capital Q upon 4. So the correct answer for question number 47 is option 3, that is minus Q upon 4. So again, for the system to be equilibrium, the net force on capital Q because of the small q and the another capital Q should be equal and opposite, then the system will be in equilibrium, right? So the correct answer for question number 47 is option 3. Now let's get into question number 48. Question number 48 says that the acceleration of the body is given by the equation 4 minus 3v meter per second square, where v is in meter per second and t is in seconds. If initial velocity is 0, then terminal velocity of the body is. The terminal velocity means the final velocity. So acceleration is equal as 4 minus 3v. Now from here we need to calculate the velocity. We need to integrate it. So we say that a is equals to dv by dt. So dv by dt is equals to 4 minus 3v. Now terminal velocity vt at a is equals to 0. Putting a is equals to 0, we get 4 is equals to 3 vt. So vt is equals to 4 by 3. Now since initial velocity is equals to 0, so the terminal velocity will be equals to 4 by 3 meter per second. So terminal velocity means the velocity when acceleration is equals to 0 to the final velocity. So final velocity, putting acceleration is equals to 0 in the expression of acceleration, we get terminal velocity is equals to 4 by 3 meter per second. So the correct answer for question 48 is option 1. Question 49. In an transformer, the number of turns of primary and the secondary coil is given as 100 and 400 respectively. The power input is 600 watt, the power output will be. See, for an ideal transformer, power input is always equals to the power output. Then only we get the transformer ratio as NS upon NP is equals to VS upon VP. This is possible only when the power input is equals to power output. So the correct answer for question number 49 will be option 3, that is 600 watt. It's an ideal transformer, so power output will be equals to power input. Now let's get into question number 50. The temperature coefficient of a resistance of a conductor is 0.0025 per degree centigrade at 200 Kelvin. Its resistance is at 200 Kelvin. Its resistance is 4 ohm. The resistance of the conductor will be 8 ohm at a temperature. So using the formula delta R upon R is equals to alpha delta T. That is, we know that R is equals to R naught into 1 plus alpha delta T. Alpha delta T. So from here we can say that R is equals to R naught alpha delta T plus R naught. So from here we can say that R minus R naught is equals to R naught into alpha delta T. So here we can say that change in resistance is equals to initial resistance R naught into alpha delta T. So delta R upon R naught is equals to alpha delta T. Alpha is been given to us, delta T is been given to us. Putting the value, we get the value of delta T as 400. And delta T means final temperature minus initial temperature. Final temperature minus initial temperature is 400 and initial temperature is 200. So the final temperature will be 600 Kelvin, right? So the correct answer for question number 50 is 600 Kelvin. That is, at 600 Kelvin, the resistance of the resistor will be equals to 8 ohms, right? So this question number 50, the correct answer is option number 3. I hope the explanation for all 50 questions is clear to all. That is all. Thank you.